Hello and good afternoon. Thanks for taking the time for our last webinar session for this autumn. Today we are talking about the energy management system, the EMS of the Greenrock systems, which is a very powerful tool. Again, same webinar tool. You've got the opportunity to address any questions via the chat functionality, and I will try to answer them afterwards. And I'm Thomas Kraus, I'm Managing Director of BlueSky Energy. Thanks again for joining today's session in respect to the Greenrock Energy Management System, or EMS. So what is the EMS all about? So basically the EMS is our software brain, which is managing the different energy flows. So I will kick it off with a description of the outline of the functionalities. Then we will talk about the access, how can we access the EMS, and then how we install the EMS and integrate it into your PV or solar inverters. Additionally, we will talk about the main options today will be the heating element integration. So how can we integrate the EMS into hot water heating elements using the excess PV energy to boil your water, to heat up your water. We will talk about e-charging integration. How can we integrate the EMS into e-charging capabilities of Keba and Schneider, which are currently out of the box possible. We will talk about wireless sockets, how they can be integrated. And we are talking about integration into heat pumps. As you might be aware, the EMS is a very powerful tool, has got more functionalities. One is integrating multiple energy sources like PV, wind, diesel generators. That will be not addressed in detail today, but just wanted to make you aware of it. Those features are available as well and are basically then discussed on a project basis. The additional functionality is also one of the key functionalities. What we are using is the clustering functionality, bringing basically a couple of energy storage systems into a clever structure that we can use a couple of different storage systems that they are starting to work together in a storage cluster. Again, something which we are happy to discuss with you once you have such a project in detail, that we can look into that. So I hope you can hear me clearly. Otherwise, just give me a shout. So what's in there? So when we are talking about the Greenrock home or business systems, in there is the EMS, which is placed in our electronics cabinet. It's in the left upper side of our Greenrock home systems. It looks like as shown in the picture. Of course, and I think I addressed that already, an interesting option is also using the Greenrock EMS as a standalone product. That can be helpful for project where the customer is not quite sure if storage is the right solution for them, but they nevertheless want to optimize their PV consumption. Or if they do not know exactly about the correct sizing of their storage systems, and therefore they can also use it, installing the Greenrock EMS as the first thing before the storage, that we can gather data accordingly and then have it very easy to size the storage properly. So the standalone product comes really with electric adapter that you can plug it in, with a meter that we can count on the grid how much energy is flowing, and an internet router, which is in that package. And it's really the start to the energy optimization of PV products without storage. So with every EMS there comes the router. So why is that? Because the router is pre-configured. If there are any changes to any local networks, like the customer is changing their internet suppliers, or they are changing their router or their Wi-Fi settings, our Greenrock is not impacted by that. So make it a more robust topics, and our router is coming pre-configured. It needs a separate electricity supply, so therefore we need a socket or a plug. And the WLAN or Wi-Fi access code can be found on the back side of the router. And of course, each router to each customer is different for safety reasons. So how does the whole thing work? We have got our router here in the middle. We are connecting basically with a fixed IP, predefined IP address to the router, so through the EMS to the router, to our router, and our router is then connected via the LAN port to the local Wi-Fi or LAN connection, and we can also access then the EMS via that route. And that is exactly the reason if there are some changes to be made on the local internet settings of the customers, the only thing is we just need to plug it in and then we are set to go. If there would be settings changes and we would rely on that local router, then the whole system would be down, and therefore there comes an additional router with that system. So in general, we have got two accessible systems. One is the live view system. The live view system can be accessed over the web address www.livemygreenrock.eu, or we can access it directly by plugging it in via the router, or of course we can also access it via the customer network. The normal way would be just really to go over the internet and access the live view of the Greenrock system. You can see in there the detailed live data. That's really live data where you can see that. And of course, in there you can also make changes of settings into the system. For example, if you want to retain a certain state of charge, which should always be in your battery, then it can be set there in there. Of course, there can also be the manual adjustments. For example, one manual adjustment could be fast charging. If we want to charge a car fast, then the settings can be set there in there online. Or we can also manually start the wireless sockets or Wi-Fi sockets. That's also a topic where we're using the live view. So the most common way is really to go over the internet to access the live view. You are getting then such a logon screen, and you've got the logon data then on the back of your router to access the system. And that's how the whole thing looks like. It's a lot of stuff in there. First of all, you will see an overview picture. That's basically we are having the storage in the center. All the documents are right now all in German. I'm sorry for that, but they are available on the system then in English, in French, in Dutch. As a starting point, I think Spanish will come soon. So what we are seeing is there's a storage in the middle. We are seeing how much consumption is currently on the spot going into the local consumption. We are seeing how much energy is supplied by the photovoltaics. You can see over here there is energy running from the photovoltaics into the system, and the consumption is running back. In this case, that's the gray shaded areas. The e-charging is not enabled. The heat pump is not enabled. The hot water is not enabled, and the wireless sockets are not enabled either. It's gray, and there is the grid. And over here you can see the state of charge of the battery. So you can see all that stuff and all that information in one view. It's a little bit bigger and then more detailed over here. You can see photovoltaics, that's the grid, that's the consumption. And also you can see certain minimal graphs also in the live view. The live view is really something to make settings and to see a quick overview, what's the situation in terms of your energy flow going on. And that's then basically the settings part of it. There you can enable or disable the different features. For example, if you want to integrate the photovoltaics, you would also use that in the live view. Over here we can see, because it's the green tick over there, photovoltaics is integrated, the battery is integrated, and the rest is red, so it's not integrated at that displayed system. And the second opportunity, what you are having, is then the portal. And the portal is more of a data center, I would say. It's not giving us on the spot real-time information. It's more on a 5 minutes sequence, and it's summarizing all the data. It's then very nice displayed on different graphs where end customers and you as a partner can see what's going on over time. But it's also available that you can pull that data down via CSV downloads to obtain that data, which can then be used for, I don't know, calculations or dimensioning topics. And in there is a overview on commercial calculation return topic is available as well. If you want, you can have a look into the demo system, what we are having. That's mygreenrock.eu. It's accessible via that internet access. And I can provide you with the contact details, and then you can access it and play around a little bit if you want. So that would be just the first touch of feel of our portal. I will come to that, Nancy. The question is, are there many settings that need to be configured based on the inverter that is connected to the system? I will come to that very, very quickly when we go in there. I just will follow up with the portal topic, just to give you some impressions. You can see the different features, and then you can drill down on those features. You can also see a summary, like a pie chart, how much is self-consumption, how much is grid obtained from the grid, and how much is surplus. You can see that all in there. And then you can get various charts on a monthly basis, on a daily basis, on a weekly basis, on a yearly basis, where you are seeing how much is obtained from the grid, how much is surplus. And you can model then basically various scenarios. And that should also be an opportunity for you as partners having that data. I think it could be a great opportunity for optimizing systems for customers, looking at the data and say, look, we are seeing still a lot of surplus, so maybe an integration into hot water elements could make sense in your case, and all those things. So it's certainly a good feedback tool for the end customer, but it's also, I think, a good opportunity for you seeing how optimized are those PV and battery installations out there of your customers, and if there can be some optimization potentials, and maybe for you then some new business. Over here we see, for example, a daily graph. That's the classical shape what we are seeing from photovoltaics production. When it starts early in the morning, we see a peak over here. Obviously it was then cloudy, and then it was sunny again, so we can see how the PV performed on that day over the time. And of course, we can then also map that with different, for example, over here, we are mapping it with two different PV inverters. There's PV1 and PV2, and then we see the total amount. So we can also drill down a little bit if we have got an east-west photovoltaic system where we have got models on one string on the west side and models on the string on the east side, that we are understanding how much energy is delivered when from which side of the PV system. And of course, we can also drill down on the consumption data to see, for example, over here, the blue one is the heating element, how much energy is drawn from the heating element, how much is the red one is the grid, and the green one is the surplus. So we are seeing the green one is the surplus over here, and that's the consumption of the heating element. So we can really drill down into details over time and seeing where does the energy come from, what runs into the battery, what kind of grid support is needed, and which consumption is at what time from which consumers. So it's a very powerful analysis tool. So from the standard Greenrock systems, we have got in our Greenrock system, there is the EMS functionality that is in accordance with the grid access point, with the meter, with the focus, of course, of self-optimization. And we can integrate up to 3 inverters from the same brand. For example, we have got Fronius or we have got SMA, whatever we have. So we can integrate 3 of those inverters without the need of an additional meter via the RS485 interface. The standardized EMS can work up to 30 kilowatt peak. If it's getting higher, it's not a problem. We just need to take care about it. And that is also important, especially talking about regulated environments. We can make sure that the EMS functionality enables us and ensures that we are complying to local rules. For example, there are certain rules, the EEG rules in Germany, which determine how much excess energy are you allowed to feed back into the grid at what time. I just read a paper, Spain is going into the same direction. In the US, the same topic is, for example, for California. You are not allowed in California to feed excess energy back into the grid over a certain time because the grid is getting overloaded because all those PV systems are supplying energy into the grid. That makes sense. And our EMS can ensure that we are complying with that and ensuring that there is no grid feedback for certain times. I think that is also important for you to know that we can handle that. And of course, if the whole regulatory topic is very much on the move right now, and if you have got certain requirements from your countries, we are happy to hear about them and look into it and can give you a feedback then if we can comply to that easily. So that is just an example of the standardized PV inverters, what we are working with. So they're all standardized in there. And of course, the number of PV inverters is growing all the time, which we can integrate out of the box. So what we are needing if we want to integrate into the PV inverter, and that is to Nancy's question. So the PV inverter should be on our list. We are needing the cabling via the Cat6-7. And the settings on the PV inverter for RS485 communication need to be activated. Yes, so on the PV inverter side, there needs to be done something. And that's basically what needs to be done is the setting of the PV inverter should enable the RS485 communication. Then the bus address on the PV inverter is to be allocated from 1 to 100. And if we are integrating more PV inverters, there should be no double S address to be signed naturally. Otherwise, the system gets confused. So, and that's how it's done then on a more technical view. We are connecting the PV inverter always via the bus 2 over here, which you can see over there into a system. And with more inverters, the last device on the bus need to be terminated with 220 ohms. And it's important if we installing it, the PV inverter needs to run. Otherwise, we can't detect there is a PV inverter around in the system. So the PV inverter needs to be running. That's basically it on the PV inverter side, what needs to be done. And we have got then other options like the heating elements. We have got MyPV, that is our fully integrated heating element that is also available in the package from us. We can integrate also other heating elements, either via thyristor or with frequency controller. In general, we cannot mix it. Either it's one of those three options if we want to integrate an heating element. So what would be a case why we want to implement a hot water element into our Greenrock systems? Basically, when we see the situation that there is energy demand for hot water, and we have got a PV surplus. So basically, if there's a PV surplus, which would then either be curbed on the PV side or runs back into the grid, either way. So we can use that excess energy via those three options and heat up the hot water to a certain degree. And of course, there is a temperature sensor also involved that we are getting the feedback then from the hot water in order that we can determine the hot water should be boiled up or cooked up until, let's say, 80 degrees centigrade, and then we stop. We do not want to overheat the whole thing. So we can basically then have a certain logic. If the hot water boiler is below 70 or 60 degrees centigrade, and if we have got excess energy from the PV system, then take that excess energy from the PV system and heat up the hot water up to 80 degrees centigrade and then stop again. So we can make those scenarios to optimize the self-consumption and the PV return. So in the system area, that is the sign of the hot water elements. Currently, it's plugged off. We can see that over there. We can click it on, and we need to turn it on. And then there is the connection searched for the hot water element. We can do also the whole thing with the integrated MyPV topic. Then there is a direct line connection to the Greenrock router of that MyPV heating element. And what we are delivering then as a package is basically the license for the EMS functionality, that we can do that from a software perspective. And we are also could deliver the heating element, which is defined over here, and purchases from BlueSky Energy. So you are getting all the components in one box. Of course, it's free for you that you can also use your own. That's how that heating element looks like. So it's basically then integrated additionally into the existing hot water boiler. And that's then when we tick on the hot water element, we need to activate the topic over here. We are selecting then, once it's connecting, the system realizes, all right, there is the hot water element available. So it's searching for it. We are selecting it. We are typing in the IP address for the hot water element, and then we are activating it. And that's basically it. So it's a very simple process that is a fully integrated solution. It's a little bit different if we are integrating it via thyristor. The thyristor is basically the device between your heating element, which might be already in place at the customer, and our EMS. And that is controlled via an analog signal between 0 and 10 volts. There are different thyristors available. So the delivery, what is you are getting from our end, is basically the license to do that. It's included also the energy meter and the temperature sensor, which is important for us that we are getting a feedback, what's the temperature then. And the heating element is basically already in place at the customers, or you organize the heating element to your liking. And that's basically the heating element itself. The hardware is something which needs to be organized from your end in that scenario. So basically, that's just a summary of the parts which are part of the delivery from us. And the last option is that we can also integrate with the frequency control that is then connected with the RS485 from the frequency control to the Greenrock EMS. And also in that scenario, the heating element is your part. You are supplying the heating element, or the customer is supplying it, and we are supplying basically, again, the license, the frequency controller, the energy meter, and again, the temperature sensor to get the feedback on what's going on with the boiler. And that's then basically integrated with the frequency control function. So that's the three options what we are having. So either you can take the plug and play solution, which is of course the easiest one, or you can use your own heating element and using then the thyristor or the frequency controller to integrate between the EMS and the heating element. So the next topic is using the excess energy for e-charging. We have got Schneider EV Link wallbox or the Keba wallbox P30 series. That's the ones which are plug and play available. We do not supply the wallboxes right now. We are discussing that if we've got the opportunity. So in this case, it would be a topic that you would need to organize the wallboxes on your own. The integration always needs to be done via the LAN of the Greenrock router. And we are delivering basically the license to activate it. And we are working, as mentioned, that you can also buy the charger on our end. So what's the main function when we are talking about the e-charging? In general, the car is charged always with the excess power from the photovoltaics. This is the most economical way, because then the excess energy from the photovoltaics is running directly into your car. Of course, there can be also the fast charging functionality if you have got an urgent need to deliver a lot of energy for your car. And that fast charging mode basically is also using the energy in the storage to back it up for more power to your car. Currently, we can only control one charging station. If you have got more charging stations, especially on commercial project, then we would need to look into that. We have done that, but that's basically not a plug and play solution. Then it's more on a project basis we are looking into. And of course, when you are dimensioning such stuff, you know, the rate of power of each e-car is different, as you all know. So that needs to be borne in mind with our C rate and our capabilities of the supplied power rating of the inverters. The e-charging symbol, that is that one. That's basically how the settings are done on the software. We need to go into that area. We then select, do we have got a Schneider or do we have got a Keba? In this case, we've got the Keba charging wall. We select that next in the software. And then basically the integration is fulfilled and the e-charging is active. The last, and I think one of the most flexible and economical ways to use our EMS for self-consumption is the Wi-Fi sockets, which can be supplied. Again, just to summarize, what is a Wi-Fi socket? Wi-Fi socket is basically a plug or socket which is put on top of the current plug, and it's switched on in accordance with certain intelligence but mainly it's switched on if certain levels of excess PV yield is there. For example, taking again the washing machine example, we are putting that smart plug on top of the current plug of the washing machine, but the washing machine is plugged on currently. We are plugging then the washing machine onto the smart plug. We are switching on the washing machine and configuring basically our system and saying, look, if there is excess energy, switch on that smart plug for the washing machine, the smart plug number 1, and then the washing machine is starting and giving the power to the washing machine if there is excess energy. We can do the same for dishwasher or any other flexible consumers like pumps or Wi-Fi routers, all flexible consumers which are not critical. Activating of the functionality in the EMS is, of course, one part which we are delivering there. And we are also supplying the 3 smart plugs. There are always 3 smart plugs in that package, which can be integrated. So if you are choosing to get into the smart plug or Wi-Fi plug area, we are supplying the license that you can enable that on a software basis, and we are also supplying the hardware to you that you have got everything in one package. So that's how the smart plug looks like, and that's basically just plugged onto a normal plug what you have in-house. And those plugs are available for the different plugging systems which we are seeing for different countries. That's over here. When we want to activate the smart plug functionality in the system, we can basically click over here. That's the smart plug symbol. And then we have got the 3 smart plugs available, which can then be set. And of course, we can use, as I mentioned before, and we can also online switch on a smart plug if we want to do that. So that's also an option what we always have if need be. And the last topic is really for the integration perspective is the heat pump. If there are heat pumps available, like air heat pumps or water heat pumps in the system, there is the unified SG-Ready code available, and we can integrate into that. So that's basically the info that the heat pump has got cheap energy, and therefore the heat pump is increasing the temperature. What we are supplying there is basically the activation license of the EMS that we can integrate into the heat pump, and we are also supplying an energy meter along with that. That's basically the package what you get from there, and the heat pump, the hardware is in most cases available at the end customer, and we need to integrate there. So that's basically the full-blown picture, and we would basically then connect on that relay onto the heat pump in order to enable the integration to the heat pump. From a software perspective, again, it's a very easy task. We are going into heat pump. We are going into that area of the software to switch that on. We need, in terms of heat pump, determine what's the main characteristics of that heat pump in terms of watts, and when should it kick off, basically. For example, if we are accessing a certain PV value, then we should switch it on. But in this case, the heat pump is using 300 watts. And if the PV is bringing more than 3,500 watts, then the heat pump should switch on if the temperature is in a certain level. So it's a very easy thing to configure, but you just need to know what to put there. And that's basically it. So it's a powerful tool, and we try to make the integration as straightforward for you as possible. There is, of course, a more elaborate installation manual available, also in different languages by December. So if you are interested, reach out to us and we can provide that to you. And to summarize again, the Greenrock EMS has got two functionalities. One is the portal, which is basically our data center, providing a lot of data which can be downloaded or visualized. And we've got the live view, which is giving on-the-spot information back to the customer. The EMS has got also an app functionality. That is, I think, especially interesting for end customers, that they can use an app for their system in order to understand when they are in the office, on holiday, on work, how their system is performing. That is, I think, a very good feedback tool for the end customers. So that is our EMS topic. As mentioned again, so I tried to address the main topics, which is really in the focus of self-automation of PV integration, and then how to get that PV access used in the best way. Integration into multiple sources and stuff, we could elaborate on a project basis, and we are happy to do so. Do you have got any further questions on that topic? No further questions. And to all participants, to you which joined and took the time to take part in all 4 of those webinars. Thank you very much for your patience and attention. We will reach out to you to get the partner certification documents to you, that you are then a certified Greenrock partner, which very warmly welcome you in our club. So far, so good. That is it. Thanks again for your patience and time, and we will send out the documentations afterwards. And you have got our contact details. Reach out to us if there are any further questions, and we are certainly looking forward to working with you and getting a lot of exciting projects on the road with you guys. Thank you very much. Okay, thanks again. Ciao, bye-bye.